Most of us understand Newton's first law at this point, that an object in motion stays in motion unless acted on by a force. But there's another thing to consider about this. What does it mean to stay in motion? It doesn't just mean to keep moving. It means to keep moving at the velocity you have in the direction you were going. If you want to have somebody move in a different direction, you got to apply that outside force. And a really good example of this is turning. What if we wanted our person here, instead of moving straight, we wanted them to round a corner like that? I've drawn this new path as a circle, and I did that because that's the easiest type of cornering motion to understand. So we'll treat this as circular motion. So if the law of inertia, Newton's first law, says that our person should continue in this direction, we have to ask ourselves, what direction would a force have to be to get us to start moving in a circle? Well, notice that my white line has started to go below my yellow line. So here it's probably a downward force, something like that. As we continue, though, now we're going a little more to the left than we'd expect if we were going to go in a straight line. So the force is turning a little more to the left. If we're going to go in a straight line here, we'd be shooting down the board, but we're turning to the left of that. And I think you can see that as I go around, the force needed to keep me moving in this circular path is an inward force. We call this type of force the centripetal force. And that's just Greek for center seeking. So what I'm going to do now is I'm going to run around a corner, and you're going to see that this inward force is absolutely necessary. I'm going to do it in a situation where I don't have enough of it, where there's not an inward force to help me turn, and I want you to predict what's going to happen. So the coefficient of friction between my shoes and the tile floor, it's pretty high. And as fast as I can run, the frictional force appears to still be enough to hold me in a turn as I'm going. So I taped some cardboard to my feet in order to decrease friction. And we'll see what happens. We'll pay special attention to the direction I go in as I try to round the corner. So I think it was pretty clear what happened when I didn't have enough of this inward or centripetal force. I kept flying outward. And sometimes people think that there's an outward force that's pulling them out as they try to round a corner. And they even make up a name for this. Sometimes they call it the centrifugal force, the center fleeing force. But that's not really what's going on. If I want to make this white curve, I have to consistently have this inward force. When the inward force is not enough, well, what am I? I'm an object in motion, and I want to stay in motion. So let's say I'm going fast enough here that I no longer can provide enough inward force to turn me. What do? And that's what you saw in the hallway as I went flying outward. From my perspective, it really felt like I was being pulled outward. But I think from the angle you guys were at, you could see that I just failed to make the turn. And it was my inertia, my momentum, the fact I was an object in motion, that's what kept me going. There was no outside force. What we need to do next is we need to study what these inward forces are. And I think you saw from this video that the inward force for me was friction. If you were trying to draw me moving in a circle, if this is me right here, the force that's keeping me going in the circle is the inward force of friction. And because I deliberately set it up so I wouldn't have enough friction, I failed and went like that. These inward forces aren't some magical new force. They're always going to be something we've studied before. So you'll see some cases in the next couple weeks where they're tension forces, gravitational forces, friction forces, normal forces. It can be any of these. But the bottom line is there needs to be some inward directed net force to cause this to happen.